At the end of this video, you should have an answer like this: a factored equation, intercepts, end behaviors, and a graph. Good luck. Okay, so Sharisse is going to show us how to graph polynomial functions today. Our polynomial is p of x equals x3 minus 9x squared plus 24x minus 16. As Sharisse has already correctly written down, this polynomial is cubic because it has a degree of 3, and we got this from the value of the highest exponent. And since it's cubic, it's going to have a maximum of 2 turning points. This will help us graph it later. Now, the degree is 3, so this function is odd, and the leading coefficient is positive. This will also help us graph it. Knowing that the function is odd and positive, we can predict the end behavior of the function. There's a fancy way to write this, which Sharisse is doing, but since we are bound by time constraints, in layman's terms, in the negative direction it goes down, and the positive direction it goes up. Now the next step is to do what Sharisse has unnecessarily written on the board: use the rational zero test to find the factor of this polynomial. This involves subbing in different numbers for x and hoping that one of them works. Luckily enough for us, p of 1 equals 0, so therefore x minus 1 is a factor. Now we can take this factor and divide the polynomial with it. This will help us get to our final equation that we'll use to graph with. Now there's a couple of ways to divide big equations like this. Sharisse is going to use synthetic division. So at the end, you should have a remainder of 0, and the new equation will be p of x equals x minus 1, which is our previous factor, and x squared minus 8x plus 16. Now draw a nice arrow to an aside and factor that second term in the equation to something more manageable. You should end up with x minus 4, which can be simplified to x minus 4 squared. Then our new equation is p of x equals x minus 1, x minus 4 squared. Now crawl on the floor to a better location and figure out your y-intercepts. Sub in 0 to the original equation and you should get negative 16. So the y-intercept is 0, negative 16. Now using your factored equation, plot the zeros. In this case, x minus 1 will become 1 if you solve for x, and x minus 4 will become 4 if you solve for x. Your y-intercept at 0, negative 16. And then take the predicted end behaviors from the beginning, and then draw them onto your graph to guide you. Second guess yourself and redraw them, and then connect the dots. Pass through negative 16 and 1, and then have your first turning point and head back for 4, and then have a second turning point and connect with the last end behavior. Now it bounces off of 4 and 0 like a parabola because it was x minus 4 squared. Now step back and admire your shakily drawn graph. You did it.